Electric vehicles are slowly but surely snatching market share from their combustion engine forebears. However, range and charging speed remain major sticking points for customers and are a prime selling point for any modern EV. Therefore, battery technology is front and center when it comes to improving these numbers. Solid-state batteries could mark a steep change in performance in these areas, and the race to get them to market is starting to heat up. So let's take a look at the current state of play. Hey everyone, welcome to our channel. In today's video, we are going to talk about Toyota's first solid-state battery car that will shock the entire car industry. So let's get started. Despite being the largest automaker on the planet by volume, the Japanese company is famous for hedging its bets and not being all that secretive about it. When other manufacturers were vowing swift electrification at all costs, Toyota said they would need to continue producing hybrids if they were to realistically serve the public. But the business is still developing battery tech, with a vested interest in selling it off to rival manufacturers who are more willing to run with BEVs exclusively. In addition, the company has also been developing solid-state batteries, which it has confirmed are on track for delivery in 2025. So why solid-state? Currently, lithium-ion or lithium polymer batteries are used in the vast majority of EVs. They have higher power density and lower weight than other practical commercialized battery technologies, making them ideal for vehicle use. However, they also have some drawbacks. They're still heavier than we'd like for their given capacity, they take too long to recharge, and they have a nasty habit of catching fire in a rather ferocious manner. Solid-state batteries could change all this. They're called solid-state because the liquid electrolyte is replaced with a solid-state material. Solid electrolytes would be far less flammable than liquid materials used presently, and thus far less sensitive to heat too. This could allow for greater current draw, as well as faster charging, as the battery would not have to be kept in as narrow a temperature range for safety reasons. Additionally, the solid electrolyte may allow use of different anode material that would provide greater energy density. In particular, scientists have long wished to use lithium metal directly as an anode material in batteries. However, in current liquid electrolyte batteries, the lithium metal anode forms dendrites that short out the battery, destroying it in the process. It's believed that a solid electrolyte would prevent this growth and could provide up to 2.5 times the energy density of existing lithium batteries. But are there any challenges to consider? Solid-state battery technology has not matured to the point of mainstream use just yet. Some solid-state batteries have been arriving on the market, but they're several orders of magnitude too small for use in electric vehicles. Challenges remain around conductivity, particularly at lower temperatures, as well as issues of high resistance between the solid materials that make up the cathode, anode, and solid electrolyte. Many solid-state battery designs require the solid electrolyte to be under great pressure to maintain good conductivity, which introduces mechanical issues around stress and fragility. Additionally, there simply isn't any infrastructure to produce solid-state batteries in mass. Automotive manufacturers have been rushing to build new battery plants to support EV manufacturing. However, the vast majority are to make up a perceived shortfall in producing current battery designs. It's likely plants would have to be significantly retooled to produce solid-state batteries, which have very different internal designs. Regardless, the tipping point at which solid-state batteries become viable commercially is nearly upon us. Several companies are investing big money in this space. Each hopes to be the first to get a competitive advantage over its rivals by having the best battery tech available. On the small scale, we already saw last year that component manufacturer Murata had developed 25 mAh solid-state batteries last year. These were awesome to mount on a PCB, but won't really help to drive anywhere. Stepping up a little but still on the smaller scale is the effort from Hitachi Zosen. The company has produced a high-performance solid-state battery of 1000 mAh capacity. However, the technology is not yet commercialized. However, electric scooter company Gogoro has cornered the Taiwanese market in electric mopeds. Their vehicles feature a handy swappable battery system, with battery swap stations dotted around the country to keep riders on the move. Now the company has unveiled a new solid-state battery prototype compatible with their existing battery form factor. This means the new battery can drop into all these existing vehicles on the road. The new battery ups capacity to 2.5 kilowatt hours, up from 1.7 kilowatt hours. It's a full 40% increase in energy density, boosting the range of any vehicle that can run on a Gogoro battery pack. However, the pack remains a demo article at this stage, and the company hasn't announced definite plans to roll the batteries out to their network just yet. Meanwhile, titans of the automotive industry are also vying for the lead in this area. Last year, BMW made it clear it would show a solid-state powered tech demonstrator by 2025, while it hopes to go into production closer to 2030. Apart from these, Nissan has gone further, revealing a prototype factory for solid-state batteries in partnership with NASA. The Japanese automaker claims that its solid-state cars could be charged up to 3 times faster than current models, while offering twice as much range. The company hopes to have a pilot production line running by 2024, in preparation to sell solid-state EVs to the public in 2028. The company also noted that solid-state tech would produce a pack about half the size of the current battery, and that it could fully charge in 15 minutes instead of a few hours. Then comes Toyota. Toyota has also invested big and is working hard with Panasonic to be at the head of the pack. The company claimed earlier this year that it would have a hybrid vehicle on sale with solid-state batteries as soon as 2025. Given the high cost of developing and producing the new batteries, this counterintuitive move makes some sense. Hybrid cars use smaller batteries than EVs, and thus the solid-state tech wouldn't inflate the price of the hybrid as much, keeping it market-suitable. When it comes to the automotive market, though, solid-state batteries are fundamentally too important a technology to ignore. Everyone from Volkswagen to Revivan is taking a look, though most of the other players aren't showing their hands just yet. Overall, solid-state battery technology promises to be a game-changer. All that's required is for the scientists and engineers to solve a few issues around the reliability, manufacturability, and cost. If those hurdles can be overcome, the new batteries should blow lithium cells out of the water and quickly take the market by storm. Even though solid-state batteries are seen as technology that could drastically improve today's fully electric vehicles, it seems the first vehicles to feature one won't actually be EVs. This is at least true in Toyota's case, since the manufacturer has now confirmed that its first solid-state equipped vehicles will be hybrids expected to debut in 2 to 3 years' time. The news comes from Gil Pratt, Toyota's chief scientist and head of Toyota Research Institute, who made the announcement during an interview for Autoline. He also mentioned that the manufacturer has made progress with its solid-state project and that development is on schedule. He did not say which hybrid Toyota will use the solid-state battery, but he did go on to explain why it won't immediately offer solid-state EVs. The main reason has to do with the size of the battery pack, which for a hybrid vehicle that still has an internal combustion engine is considerably smaller than what you see in a pure EV. However, the cost of a solid-state battery will be higher, but if the pack itself is small, then moving to solid-state shouldn't drive up the vehicle's cost too much. Pratt does acknowledge that this approach may be a little bit unintuitive, but the cost problem makes it seem more logical than at first glance. Currently, solid-state batteries are around 7 or 8 times more expensive than lithium-ion, and the cost won't come down enough by 2025 to make them a viable solution for EVs. Maybe by 2030, if more companies invest more into development, and fingers crossed, some sort of breakthrough. And it looks like this breakthrough will be coming from Toyota, and there's a strong chance it will, because the company is investing big money into it. So Toyota looks ready to take over Tesla and others with this new battery technology. And this is it for today, guys. What are your thoughts on today's video? Let us know in the comments section below. And if you liked the video, don't forget to give it a thumbs up and subscribe to our channel. And thank you for watching.